Oh, but yeah, I better go and get James. James, how are you?
Great.
You ready for the day?
Yeah.
You ready for the day? Are you ready for it?
I can't wait.
Are you ready?
I can't wait.
You ready? So we got some, today it's a bit different, mate. We're going to see Prysmian Cables. They've invited us to the factory to come and see some cable manufacturing processes, and they've given you a lovely hat and a fleece to wear, buddy.
Thank you.
So put that on,
I will.
and we'll see you shortly when we get there. So we're currently on the way to Prysmian Cables in Wales. We've currently done over 100 miles, we're nearly there. James is on the camera, so when we get there we'll do some introductions and we'll see you when we get there. We're going on the back bit.
Between 4 and 5 times between parts are normally. Obviously the way this is set up on the conveyors is we weld one to the other as one empties and moves along and it carries on then. What happens essentially is within here there's a lot of wheels and a series of these dies they get increasingly smaller and smaller as it goes along.
Yeah.
And then the last one is tailored to whatever size 1.5 or 2.5 whatever you make.
It just squashes it there.
Yeah, it pulls it through and stretches it essentially.
Yeah.
What that does is it makes it quite hard and brittle. So at the end of that, there's a process called annealing, where we run a current. Well, it uses heat, it does, but for us, we run electric current through it to make that heat, and that softens it back up again, then, so it makes it more pliable.
Yeah.
Obviously, when you bend it around corners or in the back of sockets, so it doesn't snap.
So that's finished strength. Like I say,
It's all in.
That's right, yeah. So, how heavy, how much? There's a ticket somewhere.
Yeah, and have a look what size, the different size, depending on the form, and that's what size you want.
Of course, yeah. Wow. We'll get through a lot of them. Yeah.
Do this, so what you can do is you weld one to the other, put it in, so then you can continually running up and stop at the end of everyone.
Yeah.
So we carry on with that then. This particular line is dual line, so they the blue and the brown at the same time.
Yeah.
So the cop obviously goes after the brown, forward. Separate sides, so obviously blue goes in one side, brown goes in the other side.
Yeah.
And then they through there at the same time through there.
And that's just putting that on there, is it?
Sorry?
That's putting the insulation on there.
Yeah, that's it, yeah.
Wow. So it's bare copper coming in, 2.5, is that 2.5?
Yeah,
that's 2.5 coming in there. Yeah. So you do extrusion at the same time. So you don't do one, pile it up, bring it, test it, bring it round. Do it on one.
Right. In there, I'll eat quickly from here, it goes to the cooling pot, that's just sprays water, and then it gets automatically coiled in onto the larger front. So if you get from the corner there, we've got 4 of these in rows, so this one is for the actual finished product, but the principle's the same. So we walk it all the way down there. So it's automatically coiled onto these drums. When it comes to the end, it automatically changes over to the other side. Right. And then a crane then comes in and takes it away, and then at the end of the line, and that's picked up by another HV to want the next process. We've got bins of different colours then for the different cables. This is the 6 mil cable, it's not 2.5, but the same principle. 2 7/4 head into the nerve. So then they come through the head there then, and the same principle as the other one, you through they've got a screw in there. The feeler dropped into the back, the screw turns, as you come to the front, the temperature increases, and then that's essentially just pulls on the cable then, almost like a Play-Doh roll. And that's hot, is it? That's it's 170 degrees the previous heat before it goes to the water. So if raw these, show you. So we have the tip, so the PVC, the cords will obviously run through there, then the PVC will come in at this point,
Yeah.
and run down there. They sit together like that.
Yeah.
You've got a small gap there, that allows you to feed through.
Yeah.
Squeeze it down onto the profile of the cable, and then you've got a profile of the cable then on the outside.
Just forces it
and
together.
that's what gives it the shape then.
Yeah.
Now this, I'm going to get fussy about stuff every now and again.
Yeah.
This is really important. It looks really simple, but when you see made in the UK
Yeah.
or 64Y or what year it was or something, that's where it's put on. So we have to make new ones every year, and every factory's got to do it. But this has to be done when you make the cable.
That's putting your name on it.
That's putting our name on it. So the law
Yeah.
says you've got to mark it
Yeah.
with a certain thing.
Yeah.
That's what Paul sorts out.
Yeah.
But the indenting means it has to be done when you make it. So
Yeah.
basically no way out.
That's
No
it.
fee.
Yeah.
So how far the back up there?
The entire line is wrapped from 3 meters.
And when you want to run quickly, it doesn't stay in the cold water long enough.
Right.
So you've got to be long.
Yeah.
On one machine or one machine. Yeah. One machine. Yeah.
And how many heads of thread are down there? The threads are up into like a small little grain.
Yeah.
And then it gets pumped back through the cable end, so you haven't got any PVC waste on each side.
So this is all PVC.
Yeah. It is with this type of thing, and then that goes back through then as you're cycling.
Yeah.
You get it, it's white, sometimes it's grey. Yeah, so
Yeah.
if you see it, if it's not white, it's new material.
Yeah.
If it's not white or a mixture, put it into like an off green colour.
Yeah.
It's where it's been to the cycle.
Right. Yeah. That's interesting.
Right, so once a bob is completed on the line 31, the sheathing drum, we have what's called a peril, so it's basically a curtain system which is automated, so the wheel automatically unloads. It will pick the drum up, come across the curtain and be placed in here. So then one of our test cell guys, once the bit will come in, open the door, and this basically does an online testing for conductive resistance and insulation resistance.
Yeah.
It doesn't, it basically says pass or fail, so if it passes, all good.
Yeah.
If it fails, then it goes through our more modern test tree, which basically will say exactly where the fault is,
Right.
what the fault is,
Yeah.
what is the resistance. And
Yeah.
so
Yeah.
it's basically a pass or fail. If it passes, all good. If it fails, then that's when we go for a more complex testing system.
So is that going that way?
I love this. This is exactly it.
Yeah.
I have to learn every time. I know it's taking it up,
Yeah.
but it's not obvious, is it?
It's going that way then. Right. Putting it on that drum.
We see there's plenty of wires coming together through the cording over there and causing a twist as the cable's twisting into it. So we'll show you the inputs as we go along, but they're hard. Quite a nice lay on the armour, as you can see. We tend not to aim for a gap of more than 2 of the wires as well to keep all of the protection.
What's that
over
brush?
the bed.
What's the brush is doing?
That's just to brush off any, if there's any input on the galvanized sort of thing, it brushes off anything, so we don't have little sort of spectacles going into the gun.
Yeah.
The thing to remember is it's of armour, galvanised steel. I know it says WA,
Yeah.
it's galvanised.
Yeah.
So there was a fake cable thing a few years ago, and they hadn't put the right galv on.
Right.
Because what that does is it means it rusts in the ground.
Yeah.
It's not armour.
No, that's it. Yeah.
And also there are people using it, I don't know what the score is now, you can use it as a return on a CBC.
Yeah.
So that's rusty, you know,
Yeah.
using that.
Yeah.
So it might seem really silly, tiny little thing, the galv on the wire,
Yeah.
really important.
Yeah.
Not only that, it'll cause us, so once it goes through with the sheathing to final stages, if there's any sort of nips or bits like that, it can cause a spark plug. So
Yeah.
if that gets into the sheet, you can actually have a bit of the galvanized seal wire on the outside of the sheet as
Yeah.
well. So just an extra precaution to make sure we don't have any further issues with you.
So other things, I mean, it might be more modern now, but when in my day, when I was making cable, bigger cable than this, all of this lot, that's stationary, right? You just pulled over the top,
Yeah.
slowly around. The only thing you move is the core and the finished cable.
Yeah.
In my day, they all had to move around, all of them.
Yeah.
having, so it's 154, 121 and 0.87 the bedding as well. So that's how we work it out. How many wires go into each side.
Oh yes.
So if you do a change from 4mm to 6mm, they'll have to take some wires out and put some wires in, depending on the side.
It's not, is it the number of wires?
64-B, you see a low smoke, 4mm white. It's got a length from Sheathing, so it knows exactly how much is on the drum itself. So I won't go back, it's in the middle of testing at the moment. There'll be a list of items to test, so stuff that's come off extrusion, we'll have a test on it. So obviously the guys will come and load whatever needs testing. They test, put the temperature in, put the drum in, and then basically there's an automated system where the test it sends across then into the test bay itself. So you see the brown, blue and earth are all connected up in points 1, 2 and 3. You've got your resistance, max and min, which it knows automatically from the item code, so all that's in the system itself. Then it does the IR, so as you guys will do, it does it for the whole length, for the insulation resistance, the min and max. The voltage, so it's got a class a 5-minute test at high voltage, so 2 kilovolts. If it passes, it's fine. If it fails, it means there's a slight breakdown in the core somewhere. And then what we can do is do a fault rotation then, so we can do a test to see how far exactly the break is. So you can see HV, conductor resistance and insulation resistance for all drums as well. So you said if it passes, great. If it fails, you can locate exactly where the fault is and split the drum down to that fault. So cool. 1 to 6 board in number 7. You see, it's similar to the machines in extrusion. You've got a head that comes down, that's boiling at a high speed. So when it fills up 300 litres, once it knows the lens gauge, then stop and take a cut, so we can just watch the process here. But at the moment it's just traversing that as well. You can see it ramping down, then the scissors will come. I'll take the cut. Then we've got a ramp in the machine end, so that rotates and wraps in the pallet as well as holding the tail end. So now goes down into the that's an automated system, and so we know what axis and what checkpoints to put onto the pallet. And they get loaded on top of just the machine itself. Thumbnail. What they do is load that on the top. What the cable that we've seen coming in does, again similar to that machine over there. Basically services back and forth high pace until it gets 100 meters coil in this instant. The machine slows down. You see again it kept this on the top and drops into the box. So what you have got is a reel inside the box with the fan. Over here then we've got a tin plate. So put them in the centre. We've got a slice of a tin plate with it coming across the belt. What that does is form ends in normal shape and basically goes in and punches that inside the centre of the fan. What we can see then is obviously the final product. Again, that's the labelling unit which we've seen in the other machines as well, so all down to download that is. From our side internally in the plant, we got what's called an MO number. So that number will be the same on all of this pallet, okay? The next pallet that comes along, that number will be the next number up. But this is quite important in terms of traceability for us, because what we can do is use that MO manufacturer order number. if we have any issues, a customer can ring us and take a photo of the label or whatever. And what we can do is trace back then, so we know what cable has gone into this, so what drum has that come off. We also know where the coals come from, all the QA tests that were done. So we get a full traceability and a good picture to do some investigation if we have any issues.
Yeah.
But it is an important bit of information.
Subtly, by the way, you've got to put that on the packaging. You're not allowed to write it on the cable.
I just throw that away.
I know.
Once that gets battered, that gets thrown away, and we're just left with a plain drum.
Yeah.
Flange came apart, or that's the start up of a reel.
Yeah.
Generally, when they join the two drums together.
It'll go up and then the axis will go up in the air then, and you'll see exactly where it comes from.
How was the tour, James?
Fantastic.
Did you enjoy it?
I did.
What have you spotted already, James?
Biscuits.
Biscuits. Of course you spotted the biscuits. I got a stress ball, look. So I'm going to use this on the way home, mate.
What do you think of the plant?
Efficient, clean and tidy, and all the guys seem to enjoy their job as well.
Yeah,
You know, that's the important thing, isn't it?
definitely. Our employees are great on site, to be fair.
Yeah.
We've manufactured electrical cables on this site for over 100 years. With the UK manufacturers. You know, we employ 145 people on site, generally local, and we support the local community from that perspective. And yeah, we really enjoy supplying the UK market from this location. Low voltage building wire cables generally, PVC and low smoke. We have 3 VNA trucks servicing 5,500 pallet locations, which can take between probably 100 to 150 missions per every hour. So it's quite a fast-paced distribution centre. We generally stock the best part of 4 weeks production, and we stock over 700 different product variations on site, which allows us to be able to deliver to the customers within 3-4 days is the target delivery time.
So that's UK wholesalers.
Correct, yeah.
Anywhere else?
We also ship to the Hong Kong market, so export markets, and Ireland as well.
Yeah, fine.
So we finished our tour. We're now just, the guys are setting up in the car park. We're just going to grab some tools. We've got some gloves, we've got our bench. We're going to go and do some stripping of some cables now. So this is what we do with your nice new boxes.
Yeah.
That's what we do normally. Isn't it, James?
No.
We've heard. No, we don't do that. Standard 2.5. Yeah? 2.5?
Yeah.
Yeah? See how easy that is to strip? Pull the CPC through. Yeah. Well, a lot of people still do it. We can show you. Normally, electrician will come to his back box.
Yeah.
He'll just bite the middle.
Like a little like that.
Grab it like that. And that's it. Look. Like that. And he's
Much neater way the first way.
Yeah, the first way.
In terms of the sheathing.
Exactly, yeah. And then he'll nibble that, like that.
Yeah.
Like that. And then 9 times out of 10, it's end up dented in a copper inside, you see.
Yeah.
Whereas with those, you don't dent nothing.
Oh, I see.
You just
Yeah.
it actually snaps. Bang. Look, it just
yeah, so we
stretches
got
it
called
off.
out. Corey got asked about, we got involved in a quality issue.
Yeah.
It turns out to be another cable manufacturer, funny enough.
Yeah.
And they hadn't annealed the copper properly.
Yeah.
So the tiniest nig,
Yeah.
it just broke off.
Yeah.
So he was going to double it.
Yeah.
To put it
That's
in
it,
terminal.
yeah.
It snapped off completely.
Yeah.
With 1 mil, so any could have been
Yeah.
done for probably half the size of
We
it.
had some the other day that this was out of the back box like this much. You leave.
Yeah.
You put these all the way in to strip it,
Yeah.
and when I did that, the whole inside come off. So I was left with 6 inches of copper. So then you've got to re-pull it out, but it wasn't Prysmian's cable. I shan't say what cable it was, but it wasn't Prysmian cable.
2.5.
So would you use 3.2.5 or 4, or what do you?
For
use
what?
that for any, well, would you use that for anything?
Yeah, for a radial, 16 amp radial,
Okay,
2.5.
Okay. Cool.
You could even put it on a 20 amp. But this is an armoured slice.
Yeah.
I don't know if you've seen these before.
No.
So normally you'd use a hacksaw,
Yeah, I've seen people do that.
but obviously these tools have been made to speed up the process, and these are good tools actually. It's essentially a hacksaw, and you just
You've seen it. Yeah.
rather than it gives you an even cut on the, then you'll
So
hear
Is
it.
that cutting the wires?
You'll hear it start to scrape your wire inside.
Yeah. Okay.
And give it a few turns. And if this was a bigger armoured, you could actually look through and see the scoring marks. Obviously, this is quite a skinny armoured. You just have to go with your feeling on that one.
Yeah.
Use the armour on the outside.
That's right. Yeah.
Oh, I see you're twisting the ball to go deeper.
Yeah, the balls just give it a little twist.
Okay, yeah. I like those plumbers things.
A bit like a pipe slice. Yeah, that's it. You see there, you got all the.
Yeah.
Yeah.
So that's a sheath.
So it's sliced through. Your thumb towards your chum. Yeah. If you didn't know that one.
do now.
Yeah.
Yeah.
Bit of a blunt knife, but you get the idea.
Okay. I've seen tools for that.
Yeah.
But
You can.
But
you
there
can,
was like
you can
there for
strip it up.
33 kV cables or something.
That's right,
You probably
yeah.
don't need that. Yeah. So that's galvanised steel wire.
Yep.
Yeah.
That's all the process.
That's what we saw earlier. Yeah.
So when you're making off a gland, another little trick you can do
Yeah.
is grab a piece of the offcut.
Yeah.
Yeah. And you can tighten it around there with your pliers. And that will stop if this was a bigger armoured, it will stop it splaying out because it gets quite hard to get on the gland.
Yeah.
It just stops it splaying out, yeah? Some guys will use a cable tie, but just use a bit of a bit of this. This is fine, and then you'll see this is cut for it perfect.
Oh, because that's what it was scoring the surface.
That's right, yeah.
Oh, I see. Yeah.
If you don't cut that enough, when you try and fit your gland,
Yeah.
you have a nightmare because you're going to end up with all bits splayed out.
Yeah. Okay. Ah, yeah. Because they're quite tolerant fit, tight fit. Yeah.
Yeah. Yeah, nice and neat. Yeah.
Oh yeah. Okay.
And then you could use that again
Yeah.
to take off the next layer.
Yeah.
You then slide your gland on.
Yeah. Yeah, I can see that's.
There you
Oh
go.
yeah, the gland's already on. Nice.
There you go. It's ready to go.
Nice.
Take your centre off.
Yeah.
Away you go. There you go. Yeah.
Yeah. So that do you find that they stick ever? Because
That came off lovely. That did. That came off lovely.
For the
Yeah.
length you're pulling off.
That's right.
As well, so
If you was to be making off it this long,
Yeah.
normally you would do two sections,
sections,
and you
yeah.
just
The
peel
shorter
half
the
off
easier, isn't
and then
it?
peel half off. But yeah, that did come off lovely, yeah. There we go, I've dropped James off. It's about 3 hours in the end to get back from the Prysmian factory in Wales there. Massive shout out to Prysmian for inviting us. Massive shout out to Simon and all the guys at the factory there. They run a great tight ship there. Shout out to Jonathan, the manager. Shout out to Ridgemont, Claire for organising lots of this. Yeah, it's been a great experience for me. Hope you guys have enjoyed the video. And I'll be sure to see you on the next one. If you found it interesting, please give it a thumbs up. I really appreciate it. Take care. See you on the next one.